Welcome, everyone. Once again, Mohawk Matt here, bringing you another awesome human being. And guess what? It's a scientist, and he does awesome things. Is he a scientist? Is he an engineer? I don't know. What's the difference? I don't know the difference, but you'll be able to tell. Today, I've actually got Paul Jaffe. Paul, what's happening?
Living the dream.
That's fantastic. I love the artwork behind you. It's super awesome.
That's my wife.
Excellent.
I
Represent.
mean,
Wives are great support. So, Paul here, Paul, you are an electrical engineer for the Navy Research Lab, correct?
I am.
What is that?
Well, the Navy does a lot of stuff in space, partially because most of the Earth is covered with water, and looking at the water from space is a great place to check it out from. I specifically work on two really exciting technologies. One is called power beaming, and the other is called space solar.
Ooh, those sound. I don't know what they are, but I want some. So, Paul, how long you been working at Navy Research Labs?
Over 25 years, but it sure feels like it's been a lot less.
That's awesome. And what is like? I mean, what do you do every day at a Navy Research Lab? You're like it's. I assume it encompasses the Navy and the Marine Corps, correct?
Absolutely. Every day is kind of its own new adventure depending on where we are in a particular project phase. So we could be doing testing, we could be doing designing, we could be planning. There's always something new. Just this morning, I actually came from a site where we were doing some outdoor testing in preparation for a power beaming demonstration.
Wow. So power beaming demonstration. I want some of that. So tell me what you did there.
So the way we move energy today, whether it's for the Navy and Marine Corps or just for our everyday lives, usually involves wires, fuel, or batteries. And these work great in most situations, but there are certain circumstances where it just is not going to work right? So you can think about if you
Yeah.
have a drone that's flying and if it's got a battery, maybe that drone can fly for an hour and then you have to land it and recharge it for a couple hours.
Yeah.
So imagine if instead you could just point an energy beam at it and it would just stay charged up all the time. So there's a lot of instances where we could do something like this for drones, for sensors, and a lot of different other places too.
So you call it power beaming. I'm assuming that's like you're talking like wireless energy.
Exactly. Yep.
That like wireless charging. We kind of have a small version of that, like putting your phone on something, but you're talking like not even being near something.
Exactly. This is wireless charging over a much longer distance than what we have today.
Wow. Sign me up for a couple. Put me on the order for a couple of those for sure.
How nice would it be to just be able to put your phone down wherever and it would always be charged?
Yeah, you just had like a net in your building, and it's just like as long as you're within these 30 feet, your phone just charges.
Pretty much.
Pretty, pretty cool. So, how did you get where you are? Were you like a 7-year-old Paul, and you're like, hey, I think I'm going to do some wireless charging when I'm older?
When I was a kid, I was really interested in space and I was really
Okay.
interested in energy. And I've been very fortunate to have a career path that has brought me to a place where I can work with both of those.
Ooh, that's fantastic. And you said space. I heard that you did a recent test with NASA.
Yeah. So power beaming is a technology that is required for something called space solar. So I'm sure most of the viewers know that we have some energy challenges and environmental challenges that we're going to have to deal with down the road here, and that they likely will be critical in helping us address.
Yes.
So most of our energy today still comes from fossil fuels, and obviously that can't continue forever because they'll eventually run out, but also there's a whole slew of climate problems associated with burning fossil fuels. So we have solar, which is great, and if you think about it, it's almost magical, right? You put a solar panel out and electricity comes out of it. There's no moving parts or anything. It is like magic.
Yeah.
But the magic ends when the sun goes down or when it's cloudy for a month. So one place where we could put solar panels where they would be illuminated by the sun all the time is actually in space. If we put them
Wow.
in orbit around the Earth, You have unfiltered sunlight because it doesn't have to go through the atmosphere.
Yeah.
And as long as you stay out of Earth's shadow, which many orbits can do, you have sunlight 24/7. You could think about it as doing for energy what GPS has done for navigation. But we would send the energy we collect in space to wherever we need it, whether it's a Navy base or if we're doing a humanitarian relief operation and all of the power infrastructure has been destroyed. Now we can send power to where it's needed so we can like set up the field hospitals and like get things rolling again.
So I'm sure this is not your application, but when I think of like solar beaming and pulling power from the sun, all I can think of is like a certain movie that like blows planets up.
Yeah, that's
Uh,
different.
okay, yeah. I'm gonna get a little stressed out if you're telling me you're building the Death Star over there.
No, yeah. So the difference between power beaming and something called directed energy is
Ah,
that directed energy is like what you saw in the Star Wars movie, or I guess
okay.
in several Star Wars movies, come to think of it. And power beaming is sending the energy so that you actually use it at the other end, right? Like in
Ah,
directed energy, there's not a receiver. In power beaming, there is.
so one of them's like getting punched in the face, and the other one's like doing a handshake.
Yeah, that's not a
It's
terrible
kind of
analogy.
welcome. The other one's kind of you want it to come.
Exactly.
I see. That's very cool. It's really cool to see that the Navy and the Marine Corps has kind of got involvement in space. It's probably not something that comes up a lot. I mean, you think Navy, you think water, you think land, you think, excuse me, I don't, I mean, at least for me, it doesn't always go to, oh, the Navy. What are we doing in space?
Yeah,
But
no, the Navy does a ton in space. In fact, we did America's first mission back to the moon following Apollo, where we sent the Clementine spacecraft and actually made a really detailed map of the moon and actually discovered that there is ice on the moon. There's ice in the permanently shadowed craters in the lunar poles. And this is going to be very important in the future as we start to do more stuff on the moon, because not only can we get water from that ice, but you can break that water into its constituent hydrogen and oxygen and use that as rocket fuel. So it made a super important discovery. And this is something that we're now just getting to the point where we can really take advantage of it.
so pretty much what you just told me, Paul, was that I know we've got a space force, but we've got the Navy, and since there's ice on the moon, there can be water on the moon. You're telling me that I can be on a Navy ship on the moon?
I don't know if I go that far,
Well,
but I
probably not.
suppose
Probably
in principle, maybe.
not. Maybe an icebreaker, right?
Yeah, there
Maybe we
you
can use one of those up there. No, that's really cool, and I think it's a really cool application. So, Paul, kind of tell me what's going on all in the. You kind of talked a little bit about power beaming and the wireless energy. Let me ask you this: how important is energy?
It is hard to think of something that is more important than energy, right? Because energy underpins everything we do. Like we couldn't be having this conversation if we didn't have electricity to power our laptops and the networks.
Yeah,
Every day, we obviously use lighting, we use climate control, just for transportation, whether that energy is in a stored form as like a liquid hydrocarbon or electricity. Energy is completely fundamental to our modern way of living, right? So obviously, it's extra important for the Navy and Marines because you cannot move forces and do operations without it. And I
yes,
mentioned when we send help to countries that have experienced like natural disasters and stuff, one of the biggest parts of that is like bringing energy, like bringing in generators or some way to get energy to help get things going and get people back on their feet. So
yeah.
energy is arguably more important than almost any commodity or resource that we have. And it's a pretty broad category, right? Because it comes in a lot of different forms. But
Yeah.
yeah, no, people take energy for granted, and that is a little risky because if it goes away, I mean, we've all been in a power outage, and it's like, oh man, my food's gonna go bad. I
Yep.
can't call anyone. It becomes painfully evident quickly that energy is something we depend on every day.
Well, and I think it's interesting. You really focus on that kind of that electronical side, that electronic engineer mindset. but energy is also like in our body. I mean, our
Oh
bodies
yeah. Yep.
use energy.
Food.
There's food's energy. It's
Yep.
energy's
Yep.
kind of everywhere as you go more into it. That's that's a really interesting fact, and I love learning about that, especially because I know about this much about science, and it's that I can dissect a frog poorly. So that's why we have people like you. I have a great hairstyle, and that's about it. So definitely glad to have folks like you doing this great work. So Paul, where do you think this is going? Like, I mean, we're kind of sounds like we're almost doing power beaming now. Where's this going to be in 10, 15, 20 years?
We're making really good progress. So the idea behind the technology and the fundamentals for it have been around for a long time. The physics has been clear for decades. And
Okay.
it's really just been a matter of maturing that technology and building prototypes to test things out and to figure out where the shortcomings are. Last year, we did a historic power beaming demonstration at a Navy facility called it's NSWC Carter Rock.
Yeah.
And in there, we sent wirelessly over 400 watts over a distance of over 300 meters. And this is without precedent in large part because the way we did it had an integrated safety system. We were talking about safety before, so that
Yeah.
all the people who came to see this demonstration could watch it and they didn't have to wear laser safety eyewear, and they could
That's
walk
exciting.
around, and you could treat it basically like an extension cord where it's like, oh, I have power over there, but I need it over here. But there's the building we tested in had a huge pool of water, and we beamed the power across the water. So it's like, you
Wow.
wouldn't want to run an extension cord through water, of course. So it was a
Sure.
demonstration at a small scale of how this could be useful.
That's really exciting, especially that water kind of ties back to that Navy aspect.
Yep.
Um, so very cool. So Paul, so if I'm 19 years old, or like someone, I'm not 19 years old. This is not the body of a 19-year-old. There's folks out there watching this right now who are 19, 20, 21 in college, kind of going down that path of the sciences, the math, the technology. If they're like, ooh, man, Paul has got some really interesting stuff on energy beaming. What, like, how do they get started?
Definitely it helps to be a science or engineering major, a STEM major, of
Okay.
course, because then you can really get your hands dirty and get into the guts of it.
Hmm.
That said, really anybody can contribute if they have a passion for it, right? So
Okay.
like all of this is going to require things like program management. It's going to require uh, looking at different legal aspects of it, the regulation aspects of it. All of this needs programs that have lots of people, many of whom are not STEM majors. So, really, my advice to folks is to find something that they are passionate about, that they connect with. For me, we've been talking about how important energy is. So,
Yeah.
energy, like we've said, is very important for the Navy and the Marine Corps, but it's important for our country and it's important for the world, right? So, it kind
Yes.
of transcends a lot of different boundaries. And as a father, I have two kids. I want them to grow up in a world that has a
Sure.
good future. And I know that energy is going to be a big part of that. And as we were talking about, like the current energy situation is not sustainable. So the possibility that the technology that we're working on could be part of the solution set for how we solve the world's energy problems in the future is immensely motivating. I'm also really motivated by the fact that it's a way for me to help support those that serve our country and who make enormous sacrifices to keep us all safe and to help maintain our way of life. Like, I don't know how many folks you know in the military, but they spend so much time away from their families and they
Yep.
undergo great personal risks. And to be able to do something that serves them and makes their job easier is also very meaningful to me. So that's kind of my twofold thing there, is working towards something that has benefits for the world at large to make a better world for my kids, and then also supporting our brave people who choose to serve.
That's incredible, Paul. It really is, especially as a former Marine myself. It just makes my insides all warm and tickly and super excited to have folks like you who are thinking about and care about not only the families and stuff, but also the boots on the ground, the people out there laying down our lives, doing the things. And We could not do what we do without folks like yourself. So, Paul, what else? Is there anything else that you think we should know about what you're up to, where the science is, where it's going? Anything else you want to add?
Yeah, so you mentioned before that we collaborate with a lot of folks. I have had the good fortune to work with people all around the world who are interested in this topic and who are doing work in this area. We also work with NASA. We had earlier this year on the space station a demonstration done by astronaut Jessica Meir, where we
Cool.
sent a little power receiver up to her on one of the space station resupply launches, and she actually showed how you can harvest energy from Wi-Fi signals. So there's Wi-Fi on the space station, because who would go there if there wasn't?
That's the
And
only reason you go anywhere.
yeah, right. So we sent this to her, and it's on YouTube. You can find it on NRL's YouTube channel, and
Okay.
you can see that you can power an LED, a little light emitting diode, just using the energy from Wi-Fi. And this is another way that you can do power beaming. So for the solar power satellites, you could either use microwaves, radio waves, lasers, electromagnetic waves to move the energy around wirelessly. This is the same way the sun does it, right? Like sunlight
Yeah,
is just electromagnetic energy. So we're
sure.
figuring out a way to take advantage of that even when it's nighttime. So we've done that. We also, earlier this year, launched a groundbreaking payload for sunlight to radio wave conversion on the Air Force's X-37B space plane.
Very
There's a
cool.
lot that's out there about that, and this is the first instance of hardware for solar power satellites actually being tested in space. So
That's
that's very
awesome.
exciting, getting a lot of data for that. And yeah, we're really pushing these two technologies forward. Power beaming, which has many applications, even like we were talking about, not in space, just on the ground or between points, different places, one that might be harder to get energy to. And to build a little bit on the point about energy for the Navy and Marines, right? The way we do it now usually is we have like a convoy of fuel trucks that has to be loaded at some
Yeah.
port and drive some long distance. And then depending on where it's going, it might have to be loaded onto a helicopter.
Yep.
This takes a long time, is very expensive. It puts a lot of people's lives at risk. So imagine if instead we could just send energy from a satellite straight to where it needs to go. It's an enormously powerful idea.
It's like a text message, like, "Hey, send me some energy." Like, I'm right here next to the tree. Perfect. Got it.
Yep, exactly.
That's very cool. Well, Paul, I really appreciate your time and kind of coming on and sharing your passion. I love how excited you get when I talk about energy. You're like a little kid. You're like, yeah, energy.
So, as I mentioned, one of the biggest benefits for my work has been that it's taken me all over the world. I've gone to countries all around the world for conferences and for demonstrations, experiments, and workshops. Italy, Australia, Korea, Japan, many, many different countries. That's been very exciting. I've also had the unique pleasure of having an idea that I came up with realized, built, and launched into space and have it actually operating in space. And that's a remarkable feeling to know
That
that
is pretty cool.
something went from your head, became hardware, and is in space and is helping to find the way towards a new energy future. So I've also had the opportunity to spend time with our sailors on submarines, on ships, which is really a remarkable experience to actually go out on some of the ships and submarines and other places where folks in the Navy Marine Corps spend most of their time. And I've also been very fortunate to work with many astronauts and many Nobel Prize winners, people who I had in large part idolized as a kid. And here I'm talking to them and working with them, and we're working on things together. So that's also a really big plus, a really big benefit.
That's very cool. That's very cool. Well, excellent. Thank you, Paul, for sharing so much with us. We really appreciate it.
Thanks, Matt. It's my pleasure. And thank you for your service.
No, you're welcome. Thank you. So you all heard it there first. The biggest thing I took away from that, from Paul here, was that all you need is passion. I bet you a lot of you out there have passion. We want to hear where you think energy is now related to Navy Marine Corps, what we're doing, and where it's going. Paul gave some good insights, but as he kind of mentioned, you are the future. So please tell us where you think it's going and how you think what we can do with it. Maybe you could send something up into space working for the Navy. You never know. So thanks for tuning in. And as always, have a great day.